All right, so I'm just going to go through this fairly quickly. A lot of the course in the past used to be about Fusion and using Fusion, and it was hands-on, so that you would be using, creating your first Fusion project during the class. That might be a little bit difficult if you're Zooming at the same time, but I encourage you to try it if you can. But let me just give you the background. This manual that I'm going through, the user guide, it's available on the website under Tools and Instructions. So CNC router for people that are brand new. Also, if you're an expert in either Fusion or CNC, please let me know so I don't look like an idiot. Yeah, so here we go. The CNC is set up quite a bit like the 3D printer if you've used that, but it cuts material instead of deposits material. If you look at the bed in the CNC room, hopefully everybody's been in the CNC room, but if not, what you'll see taking up 90% of the room is this device here. It's a CNC router, and by router is typically the arrangement, as opposed to a CNC mill or other device. You have a bed, and then you have this gantry that goes along the x-axis, and then within the gantry you get this spindle, which floats along the y-axis, and then you also get a z-axis going up and down, and that is determining your height. We have lots of X space, we have lots of Y space, but we don't have very much Z height to work with. So if you're wanting to do a life-size bust of yourself, you might have a bit of trouble doing that because it just only reaches about 2.5 inches high. Lots of things that CNC can be used for: engraving, wood relief, routering. The handiest thing for me, there are two real big advantages for me. One is doing a complex cutout that you would otherwise have to try and do with, say, a jigsaw or something. This cutting out curves is nice and easy, where you can work on a computer and then transfer it over to the machine. I've done some aluminum mold making before. Aluminum on this particular machine is not really very viable, but if you go super, super slowly, I guess you can do it. Yeah, I'll just keep going here. So what do we do with a CNC? The reason we have this course versus just a simple checkout is using the CNC, getting it to start is actually pretty straightforward. The hard part is coming up with the 3D model and then translating that 3D model into a tool path, which is represented in G code. That's the hard part, and so that's what we'll be covering mostly today. In Fusion 360, which is what we're using, there are other tools, but I guess we have to choose one, and we chose, I think, the most common one. You start with a CAD model. From Fusion, you go into the manufacturer part of the menu, and that manufacturer is going to lead you through some steps to get you to produce a G-code file or a tool path. It'll allow you to do a simulation. And if that simulation is okay, then you can put out a post process or perform a post process. That post process is what produces a G-code file for you. You take that G-code file, which is something.ngc, over to, say, a USB stick, and then you put that USB stick in the Linux CNC PC. And then you're now in the mode of using the Linux CNC PC to instruct that CNC machine. Any questions so far? Okay. For the nerdy among us, we've just a little background on what kind of hardware we're running. What happens during CNC is you have a PC that is running Linux CNC, which is a dedicated operating system. It's a version of Linux, and because it's CNC needs real time and not threading or shared processes, it's a dedicated OS. That Linux CNC talks through the parallel port to the Gecko G540 stepper controller, and that stepper controller controls the stepper motors that control the X, Y, and Z movement. All right, don't hesitate to holler. Safety checklist is just like anything else, any kind of tool that spins. No loose clothing, wear eye protection, make sure that the water is flowing. We used to have a vacuum. We're currently in the process of regaining that vacuum, but when it is available, you should turn it on. Otherwise, that room gets really filled full of wood dust. Other items are always use a sacrificial bed, or that is a piece of scrap material underneath the job. If you envision your milling bit cutting through your stock material, but stopping just when it hits the bed, then for sure you'll be gouging up the bed. It's just it's not that predictable a process, unfortunately. And there's the tolerances aren't that tight. Always use a piece of sacrificial scrap. And never leave the machine unattended while processing a job. One example is when I was there using the machine one day, it's a coupler that couples the stepper motor to the spindle, just broke. And good thing I was there, because it was proceeding to gouge its way right through the bed. And that kind of stuff happens, so that's why you need to be there. All right, software prerequisites. It used to be kind of complicated. It's not anymore. We just install Fusion 360, and that contains a plugin for doing G-code and the manufacture process. So that's all good. Fusion 360 is starting to clamp down on the hobby users. Right now we get the software for free, but it's now getting more and more limited. So unfortunately, they're cutting away on some of the bells and whistles that we used to enjoy. But that's okay. There's still most of the functionality that works fine. And if you need to get something done, there's always a way to do it. It just might be a little more cumbersome. Everybody installed Fusion 360 yet? No? Can't really tell. Okay. So yeah, it's a good thing. It's pretty quick. You need a bit of a powerful machine to run it. It's kind of a hog.
Does it work on a Mac?
Yeah, I think it works fine there.
Okay.
Yeah. Okay, first bit of terminology is the hardware. You may have run into collets before, or maybe not. They were new to me. So rather than a chuck, which you would see in a drill press, the CNC router has a collet system where you take your bits, and they need to be precisely the same size as the collet that you put them into. Collet looks like this. You put your bit into here, and it's really got virtually no clamping diameter. It's just your bits will fit quite tightly into this right-sized collet. You can get those. I recommend ordering them in from China or something to get a whole set. The Space also has its own set, but I kind of worry about them getting lost or whatever, and then you go to do your project and you're out of luck because the 3/8 collet is gone. So they're cheap if you order them from China, not cheap if you order them locally. When you get them, some people have made this mistake. Get an ER16 size collet. None of the other size of collets will work. The ER16 ranges from about 1/8 of an inch to 3/8 of an inch shaft. What I tend to recommend is when you're ordering bits, just order a 3/8 shank. A lot of them will come in 3/8 shank anyway, but it's the most common, and you can it just means that you only need one collet, and it'll work just fine. Okay, two good places, KMS Tools, of course, and there's also KBC Tools in Delta, and they ship really quickly. You'll get it in a few days. Their selection is a lot better for milling tools. Okay, as a starter kit, if you want to get into milling, you essentially want a fine bit and you want a coarse bit, because you don't want to be doing the bulk of a large project with a 1/8 end mill. And similarly, you know, if you need to get in a groove or something tiny, you can't really do it with a 3/8 end mill. So I recommend getting a 1/8 flat mill and a 3/8 flat mill. And then to do inside curves, fillets, you will need, say, ball end mill. So it's good also to have a 1/8 ball mill and a 3/8 ball mill. Also, please grab your safety glasses, and I mentioned this in the video that we're going to see. You should have a small USB drive. The PC that we're using in the CNC room is really ancient, has a tough time loading large USB drives, and it takes a long time. It will eventually load them, but save yourself some time and find a small USB drive. Okay, so let's talk about fixturing. And now we're going to the part where we've finished our 3D model and we've finished generating the G code. Now we actually need to router this thing out. There's a few different ways you can fixture materials. And by fixture, I mean the process of taking your piece of stock, like a 2x4, that you're going to router things out of, and mounting it to the bed on top of sacrificial board, so that it's not moving around. The CNC router exerts a lot more lateral force than you would expect, than you would ever, you know, put yourself if you're doing it by hand. And it also, because of the screwed flutes, it also pulls up on the material quite a bit. So there's a few different ways you can do things. Double-sided tape works great, as long as you have lots of surface area and a nice smooth surface on either side that you're trying to tape to. Perimeter taping will kind of work if you're, you know, say using styrofoam or something along those lines. I wouldn't do it with anything that's got some weight or rigidity to it. Perimeter clamping is quite common. If you look in the CNC room, you'll also see some quick clamps, and those can be put on the edge of your material. The problem with the quick clamps, though, or anything that's kind of comes above your stock material, is you run the risk of your spindle shoulder hitting, running into them, and that can be a bit of a pain. And also just keep in mind that unless you've told Fusion that something is there that isn't air, it'll assume it's air. And so Fusion will just keep carrying on right through your quick clamps as if they weren't there, and cause damage. My favorite method, I think most people's go-to method with wood milling, is you just take some stock and you take your sacrificial board and you just drill holes through all of it. And then the bed itself has T-slots, and you can use these T-slot bolts to come up through the bed and then into your material. Put some nuts on top and it won't go anywhere. There's also things like T-slot vices, which we don't have, and also the tape / crazy glue / tape method works really well. It's if you, but not so much for wood because it's so porous and it doesn't really you know, take the tape as well. But if for metal, for say aluminum, if you've got nice flat aluminum that you want to tape to another piece of flat aluminum, the tape and then crazy glue between works great. Oh, I'm gonna enter somebody or admit somebody. It looks like GHash is joining again. Okay. Any questions? Everybody's pretty quiet. I guess it's because they're on mute.
I have a question.
Yep.
What kind of tolerance could we expect from this CNC router?
Not a lot. You will find that the gantry being, so there's two things that affect the tolerance in our situation. One is the gantry really wobbles a lot. There's a noticeable, when the gantry is trucking along and then it actually hits the material, say the pine or fir that you're routering, you'll see the gantry actually flex. So that's not great, and that affects the tolerance, as well as the bed isn't super flat. So I would actually count on about 1/16 of an inch, or not into thousandths of an inch, that's for sure.
Thanks.
Okay, but we do have a CNC mill, a metal mill that is coming soon, and that's got great tolerance. It's got maybe 2/1000ths of an inch tolerance, so that has nice stuff. Do you plan on using metal or wood?
I had assumed it was just going to be wood, but if you have a metal CNC mill on the way, that's fantastic news.
Yeah, it's
Do you
actually
know?
there. It's just not prime time yet. We're trying to establish a CNC committee, so that we can actually get those final steps in place so people can start using it.
Nice. Do we know what kind of, like, what model CNC metal mill?
It's so if you go into the metal shop, it's a Bridgeport clone, and then we hand built. We
Okay, yeah,
manually
that thing.
retrofitted it. Yeah,
Right on.
yeah. No brand whatsoever. Maybe one day we'll get a Tormac or something like that. That'd be nice. Okay. One common issue in fixturing is, so you typically have your stock material and something that you want to cut out of the stock material. At some point, you're going to be you're going to be at your final stages of cutting out that thing that you're trying to create. The only way to keep it in place in those final stages is with tabs. So in your models, you should always remember to get tabs of wood strips that keep your piece to the stock material. Okay. It's hard to give you guys like a full rundown on CNC. It's actually a pretty big topic. Fusion 360 alone is a big enough topic, but hopefully during this session we're giving you enough information that you can get started, and we're always around if you have any questions. All right. I will give you this list. You can always refer to this list of how you get your G code loaded into Linux CNC. We also covered it in the video, so I'm just going to let you read these steps at your leisure, and then also we'll be watching the video later on. So just skip over that. Also, this process of touching off and setting origin, I'm not going to get into that because it's much more easy just to see how it's done on the video. Okay, Linux CNC is software that runs on Linux that looks like this. As you can see, it's kind of retro, but that's okay. I will take a little bit of time here just to show you what the interface is, because it's kind of weird to look at the first time. So when you turn on the CNC bed, you will still need to do two more steps to turn the Linux CNC machine on. One is to click this emergency stop off, and then to click the power on. And once you do that, these controls will enable. And the way you interface with it is you pick an axis, X, Y, or Z, and then you press the plus or minus buttons to direct them around, to direct those axes around. Or you can use the arrow keys on the keyboard, which we show you in the video. One really important thing is by default, the max velocity in Linux CNC is 300 inches per minute, which is really fast. So if you drop that down to about 30, then things will be a little more realistic. Okay, it's for future reference. You can look at this step-by-step process. I'm not going to read this off. It's going to be too boring otherwise. Okay, let's step over into Fusion. Okay, can everybody see my Fusion screen? Okay, so today we are just going to go through a sample project, something really simple. And we'll just go from beginning to end to designing it into creating the G code. Okay.
Hey, Sean, just a quick question if you don't mind.
Yeah.
Just to clarify, sorry if it's a kind of an obvious question, but
Sure.
The end file that we just need to bring in would just be the G code file.
Yeah.
So we could like use SolidWorks, any other CAD program, any other CAM program. Yeah. Okay. Just wanted to clarify.
Yeah, for sure. That's no problem at all. Just be sure to generate for Linux CNC because there's so many flavors of G code. It'll be different probably than the defaults. Okay, so I've got into Fusion, and the first thing I'm going to do is set one preference that really matters. So I go into my name and then preferences. Come on, preferences. Okay, and the only thing I'm going to worry about is this thing right here where it says default model orientation. I'm going to select Z up because for some reason the default is Y up, and Y up doesn't match what the CNC bed is like or what Fusion model is like. So, you know, or intuition. So I don't know why they did Y up, but anyway, choose Z up, click OK, and then reboot your Fusion session because your new model needs to have that default first. Okay. All right, so let's go in. First, when you are in Fusion, you create your right mouse button, click, and you create a new component. Okay, it is possible just to design your sketches and your bodies right in the root of the document. But if you ever want to, say, merge one component with another component or do something like that, then it's a real hassle to try and move those files that are in the root and move them into a component that you can use as a component. Okay, and we will call
Can I just ask a quick question about that preferences? So if I have an existing Fusion model that I want to base that off of,
yeah.
Do I need to create a new model with those preferences, or can I just change the preferences and reboot?
I haven't had any luck changing the preferences, but what you can do is when you go to the manufacturer part, to creating your G code, you can use it as is. What you go in, rather than the default mode, you go into a mode that prompts you to select what you want as the x-axis and what you want as the y-axis, and it'll essentially walk you through that.
Okay.
It's not impossible. It's just a hassle more than anything. Okay, so I've got my my document here. There's really nothing in it. So what I'm going to do is create a sketch. Okay, create sketch. And if you notice, these little you know, orientator things are a little bit weird to look at first, but essentially you can sketch on the back plane or the bottom plane or the side plane. I think of them as, and those correspond, I should say, bottom, front, and right is what you would draw on. So I always choose the bottom. I'm going to click that and just go through something really simple. So I'm first of all going to create a rectangle. I didn't forward the part that I'm going to make, but you'll see it now. You'll see what I'm after. So I'm going to do a rectangle and make it a center rectangle. Click in the middle. Okay, and I'm just going to do that. Now, if you click D for dimension, there's also a way to get Fusion to find this in the menu system, but dimension is something you'll be using a million times. So let's just learn the shortcut, and that's clicking D. You click D, you touch the line that you want to dimension, and I'm going to say 1 inch. No, let's say 2 inches. Okay, even though we defaulted to the metric mode in this, it'll also accept any language as an input. It'll display it as metric though. Okay. Incidentally, let's just change it over to inches since I started with that. And that's, everybody asks where this is, and it's so obvious that it's hard to find sometimes. So you just click in document settings and choose inches. Okay, let's do this again. We're gonna hit D for dimension, and then we're gonna single click the line that we want to dimension. And I'm gonna do that, but then I see, wait a minute, I'm gonna be running, typing in the same value that I've got up here. So I actually don't wanna do that. What I wanna do is escape. Escape is always your friend in Fusion. And then I'm gonna hover over this dimension, and it tells me D1 is the variable name that it's created for the first dimension that I typed in. Okay, so now I can go over to my other axis and just say, well, D for dimension, click the line, pull away, and then I'm going to type in D1. So if I change this 2 up here to a 3, then they both change. Okay, that's a nice way. The more you can use parametering and constraints in Fusion, the more you can design with intent, as in the intention is that this is a square that I'm putting down. The more scalable and the more reusable your designs will be. All right, so I've got that, and let's finish the sketch. And then I'm going to do an extrude operation. So I'm not used to using the menus, so bear with me. Okay, so extrude, or E is a shortcut. I'm going to click extrude, and then I'm going to click the object that the face, or the part of the sketch that I want to extrude. And I can either pull up on this thing, or I can just enter a value. I'm going to enter a value of 1/2 inch. All right, so that's all there is to that. We're going to make it a little more interesting, and we're going to create another sketch on top of this square. So create sketch. So here, I'm backing up here. I'm right mouse button clicking, and then I'm choosing create sketch. And that was after I chose the face by clicking on it. Now what I want to do is I want to put a circular rise boss on this face right here, but I want to make sure that it's in the middle. So I'm going to do 2 things. I'm going to create a line, and to do that I can either go here and go line, or just L. Okay, L. I'm going to, Fusion is snapping to this corner, so I'm going to choose that, and then I'm going to snap and choose the other corner. Then I'm going to do the same thing for the other way. Okay. Incidentally, I should mention that because we've chosen 0, 0 as the center for our rectangle, we're also going to get a snap too for the middle here, but I want to show you how to do it when you're not in that case. Now I'm going to escape. Escape gets you out of the mode that you're in, and right now I was in line mode. And I'm going to click once on this line, and I'm going to click X to make it a construction line. Okay. And then I'm going to do the same with this line, click X, or right mouse button click. But, well, let's just do it that. Normal construction, X. So these construction lines mean that Fusion won't assume that I'm trying to treat these triangles any differently than the other components. Okay, so now I'm going to create a circle. Come on, circle. Center point. And I'm just going to click where those 2, because we've done 2 crossing lines, Fusion will allow you to snap to that. So I'm going to click there, and I'm going to pull out, oops. All right. I'm going to pull out that far, and I didn't care about this the diameter. Also, but I do care that that's not a construction line. So let's do this. Construction line toggle, and I'm going to dimension this diameter of the circle. Okay. And I want that diameter to be 1.5 inches. All right. Now I'm going to create an inner circle, and so I'm really just doing the same thing over again. I go to circle, center diameter is what I meant to choose before. Click here, and then I'm going to click that, and that happens to be the value that I want, but I'm just going to go and dimension it anyway because I like to know what everything is. I want this line to be not a construction line, so I'm going to click X to make that, and then click Escape to get my cursor back. Everybody with me so far? Is it all good? Okay. Now, all I'm really trying to do here is build something that's got a rise in the middle. So I'm going to finish this sketch, and I'm going to extrude. And Fusion will guess at what I want. Right now, you see how Fusion doesn't really recognize those construction lines, and that's not working for me. So I'm going to go back into the sketch. Click, click. You can name your sketches. I'll call this circles. And I'm just going to edit it. Right mouse button click, edit sketch. I'm going to click that one line that I want to be a construction line or a non-construction line, and I'm going to select it there. Now I finish the sketch, and then I'm going to go back to that extrude operation that I wanted to do. Okay, now you see that because we don't have a construction line here, it's a real line. Fusion is now making different guesses at what I want to extrude. So I select this surface. Keep in mind too, which is pretty common for anything regarding Fusion, is that it will bring up a dialog box. The minute you choose a command like extrude or whatever, it'll present you with a dialog box. And if you step through each of the questions, you should be in good shape. The first thing it asks for is a profile, which we've already selected. They call that a profile. These defaults typically work. And again, before we have this little slider that is allows you to do this extrusion operation. So I'm going to put in 0.25 of an inch, and then that's my whole operation done. All right, how's everybody doing? Okay. I will, now we're to the point of being able to actually start the G code. Oops. Force a habit. Okay. So right now we did all this in design. Fusion has several different modes. The only ones you'll really use are design and manufacture. Maybe you'll get into rendering and animation or drawing, I'm not sure. But design and manufacture are the two ones we'll use today. Manufacture now is taking your 3D model and trying to get you into creating G code. Okay. The order of operations that you need to do is first you set a setup. You create a setup, and that setup refers to how you fixtured the stock material onto the CNC. within setup, within any given setup, you might have multiple operations. That operation might be, say you have some drilling operations and some facing operations, and some pocket and contour operations. Those are all operations within that same setup. But as soon as you need to, say, flip that project over and fixture it again, that's a new setup. Okay, so let's just start with our first setup. I click on setups. I go new setup. And now Fusion has just guessed at what I want for a setup. You see how it's superimposed some stock material over top of what I want to create. And, you know, it's not a bad guess on Fusion's part. I would probably use some stock material that is about that same, you know, just a little bit bigger than what I want to produce. It always adds a little bit of buffer. So let's go over into these options here. So Fusion has guessed at everything correctly, and that it's a milling operation. They've defaulted to the orientation that is of the model. So what the orientation that Fusion has guessed for the G code has been the same XYZ orientation as what the model that we were working on. You don't have to accept that, but that's the most common thing. And the origin, it's asking us to select a box point. So you see how this button is blue? It means that that Fusion wants us to select a stock point from the box on the stock material that we've got. The one I always choose, because it's an easy reference, it's nice and close, is that point that is at the top of the material. It's on the left-hand side and it's on the frontmost side. Okay, so that's the point I choose. And then you need to remember that when you go over into your Linux CNC session, when you're setting up the spindle, you're going to touch off the spindle at exactly that same point. Okay. All right, so we were only done one of the tabs here. So we've selected a stock point and selected material. We're going to go into defining the stock a little bit better. So these offsets are things that often change. The side offset, it's giving us, you can see here, it's giving us a little bit of space on the left, right, and front. Side offset, I actually want that to be 0. Okay. And also on the top, I'm just going to be creating the model right at the top of the stock material. You don't have to, but let's do it. There, so I've made some, I'm telling Fusion that the only thing that is that on the bed that it needs to worry about, that isn't going to have things to run into, is exactly these dimensions. If, for example, you had a long 2x4 or some piece of wood that is you know, not like that, then what I would do is actually put in some stock material, like you know, maybe make it 10 millimeters wider or 100 millimeters wider. Oops. If your stock material actually looks like this, then put it in like that. And then you know that Fusion isn't going to run through it as if it's air. But let's just go back to our regular piece. All right, so now we've done our setup. Any questions before I move on? No? Okay, let's start with an operation then. I right mouse button click on our setup, and I'm just going to say new operation. We don't have any drilling operations to do. We do have some 2D milling. Okay, 2D milling versus 3D milling. In theory, what 2D milling does is it moves X and Y in any given step. It's just going to be moving X and Y at the same time. Whereas 3D milling, 3D milling, it can conceivably use all three axes at the exact same time. So you could have something, you know, climbing a pyramid or something.
So
good.
sorry, Sean. So like 3D milling would be used, say like a concavity, like a bowl shape almost, like the inside.
Yeah, you can definitely do it that way. What you'll find though is that 2D can do that as well. It's just in the approach, 2D is going to do, you know, do one layer and then drop down a layer and then do that. Yeah, I think Simon called it 2.5 axis, and that's kind of the way it works. But the real difference, the difference you need to care about most is this 2D versus 3D really affects how Fusion will generate the tool path. In 2D milling, you need to tell it, it's kind of a stupid process. You need to tell it what to mill. Whereas in 3D milling, you need to tell it what not to mill. And let's just maybe, let's do 3D milling adaptive clearing, and I'll show you what I mean. So 3D adaptive milling. Incidentally, I actually recommend 2D milling for most of your steps because it's most straightforward. Let's see what Fusion is prompting us for. So first of all, it wants a tool. We need to tell Fusion that what we want is, oh, looks like the arrangement is a bit different. Fusion's changed this since the last time I was in, but that's okay. Okay, say I want a 1/8 inch ball mill, or that's the tool that I've got that I want to use. I've just selected from this list, and you need to poke around these libraries to find the tool that you want. You can narrow things down a little bit. Man, they've really changed this a lot. But anyway, you'll eventually find the tool that you need. Select that. So now I've got this ball end mill selected. If we go into Fusion's mockup, then you'll see this ball end mill prototyped. Okay. Boy, Fusion, unfortunately, Fusion, they give a lot of stuff away for free, but they're not afraid to just completely change things on you. So be aware of that. This preset wasn't there at the same time, or the last time I was in. Anyway, not to worry. It's guessing at the kind of operation that we're doing. You'll notice that none of them are wood. And that is kind of a pain. And the reason is because wood is so inconsistent from, you know, from oak to balsa wood. You just don't know. And so neither does Fusion about what kind of assumptions it should make about the hardness of the material. So I think the closest thing to most woods for me is probably plastics. Okay, so let's just choose roughing plastics. From that information about characteristics of the material, Fusion is going to make some guesses at what the spindle speeds and feeds and speeds should be. So, and they will be completely incorrect because our CNC router is quite underpowered. And like I mentioned before as well, it's got a lot of play in the gantry, so it cannot do any aggressive cutting. Our spindle will do 20,000 RPM, but we can't keep up to the speeds that 20,000 RPMs would need. So let's just put this at a default of 5,000. That's what I always use for our RPM speed. Now the surface speed, these are things, once you set the RPM and you set the surface speed, most of these other parameters will be determined, such as feed per tooth. You can either set the feed per tooth or the surface speed, but you can't set both. So feed per tooth, a nice feed per tooth is probably, say, 0.25 millimeters, or I'm not sure what that is in thousandths of an inch. So having set selected the RPM and the feed per tooth. I'm pretty comfortable that that is something I can live with. We'll select OK for that tab. Okay, now we're
Could
going to
you
yep.
just explain a little bit of what feed for tooth means?
Okay, so as your milling bit is traveling along, it's going to be taking shavings off of the material. It's that thickness of the shaving that you're really talking about. How much one flute will be cutting on one revolution. One thing that's really relevant in milling is, and you don't really think about in other cases, is if it really matters if you're using a 1/8 milling bit or a 3/8 milling bit, because what you care about is the speed that edge, that front edge, is traveling, and it's a huge difference between a 1/8 and a 3/8 at the same RPM. So luckily, Fusion just figures all that stuff out for us. And all I can say is be conservative. Also, when you have a new model, if you recall that when we saw Linux CNC, it's got a max, what do you call it, velocity. Always set that max velocity to be nice and low, 30 inches per minute, the first time you try a job out. And if it's cutting well and you can tell the machine isn't bucking or laboring or anything, then you can bump up that value. But it's just a nice safe thing to do. You don't have to completely guess at what the parameters need to be here. You can control it when you're in Linux CNC software. Okay, so let's just go with that. And then the next step is geometry. So because we're doing milling, 3D milling, all that 3D milling cares about is a bounding box. So I'm going to go with defaults, and this is actually just a demonstration because we're going to do 2D milling in the final thing. So let's just see what Fusion does here. You can see it's calculating. Yeah. So Fusion, 3D milling, Fusion is kind of taking the cognitive load and just saying, well, that person doesn't really know what they want, but I'm just going to go for it. And you can see because we took a ball end mill, and Fusion knows that this surface is supposed to be flat, it's taking extremely small cuts, trying to emulate a flat surface with a ball end mill. It's also gone in here. You see how it's just figured out the entire tool path? That's what 3D milling does. So we don't really want to do that. There's some projects that are very curvy, for example, you probably would want 3D milling, but starting out 2D will work for just about everything. So let's start with 2D milling again. A 2D pocket. Okay, pocket is when you need to mill out this area here, and a contour is when you need to mill out this area here. Some little jargon for you. Let's start out with a 2D pocket, and like before, we're going to get prompted to go through all these steps. Let's select a tool, and I'm going to go with my favorite 1/8 flat mill. And just like before, I'm going to bump this down to 5,000 RPM. Incidentally, 10,000 RPM won't kill anything, but it probably will burn your wood. You'd have to be moving really quickly, and probably more quickly than the machine can handle, if you're to get 10,000 RPM not to burn something. Okay. I have 5,000 here as well. And I want my feed per tooth. I think we went with 0.25 before. Okay, we'll go with the same. And then we click OK. Oops, I forgot to select a geometry. So we've gone over into this geometry tab. we're going to select the pockets that we want to contour, that we want to cut out. So we just select this bottom surface, not this top, because if we selected the top, it would be essentially milling nothing because it's just at the very top of the model. So we want to select this surface that's at the bottom and then click OK. All right, so at this point in the game, you've created a hole. Let's do a simulation on it. You can right mouse button click on either the setup or the operation and just click simulate. And you get a little play button at the bottom. It's spiraling down into the material, and quite often that can take a long time. Let's click stock on so you can see what's happening there. So simulate's a really useful tool. If you can't get it to simulate exactly what you want, then by all means don't take it over to the CNC and hope that it works for some reason. Okay. So let's also do another operation here. New operation, 2D milling. Let's do the contour that I talked about. Okay, so it's remembered my choices from the last time, so that's kind of nice. And also the tool that I selected. Let's go into the geometry, and it's asking us by the blue highlighting, it's asking us to select a contour that we want to surface. So essentially, oops, come on. Okay, that is the contour that I want to do, as well as that line out there. So I'm choosing the lines that fully describe the area that I need to CNC. Okay. And then these other options too, you'll get into those. This is, for example, how high the spindle needs to come above the material, either if it's going, if it's finishing an operation or traveling across the material. 99 times out of 100, I will just select defaults for this. There are also ways, say for example, you don't want to go a whole 1/4 inch at a time. You can select multiple depths. And in this case, I'm saying, well, only go down 1 millimeter at a time. And that matters, you know, for things like hardwoods or definitely for steel. But I'm not going to do that. Now let's do it anyway. What do you say? Okay, and then this linking is not something I ever use anyway. So we're good to select OK. Incidentally, by the number of options that you can, you've seen so far in Fusion 360, it takes a long time to learn all the ins and outs, and we're definitely not going to try and do that tonight. But there's so many good materials out there that you'll be fine if you just Google it. Okay, so let's do a simulation on this part. So now it's going down in levels. You can't really see it, but the spindle is dropping down a little bit every time it goes through. So I gave some bad advice there when I told it to do a pocket, a contour on that outside edge. What I really wanted was to do that entire surface, but that's not what a contour option is, so I need to fix that.
Sean, I have a question.
Yeah.
So the clamping that's holding it down to the bed, I assume is outside of this.
Yeah.
Rendering.
Yeah.
So if if for whatever reason you put clamping inside of it, is there a way to have like a no-go zone where the drill doesn't go? Or would you ever recommend doing that, or just avoid doing that entirely?
No, it's a really good question. I would avoid it, because it's going to be quite tricky to get Fusion to avoid that area. But it is possible to model up both your fixture and your model.
Okay.
Yeah, you can do that. What I kind of take the coward's way out, and I just put my fixturing way outside and something that I know is not going to be hit by the operations. Fusion will take a safe approach in traveling over top of the topmost point of the stock, for everything. So you're kind of safe in that respect, but if you have something that goes above that stock material, you do run a risk of hitting it.
Okay.
Okay, let's do another operation here. Oops, come on, I'm hitting escape. And let's just do adaptive clearing for the other operation. We want to, we've defaulted to that same 1/8 flat end mill, and it's going to want us to select a pocket. I'm just going to select that surface there. So now we've given Fusion enough information to know that I've got to get rid of that entire surface. And I've not done any roughing step downs. I'm just doing the whole thickness in one go here. We'll simulate that. You can fast forward. Excuse me. I need some tea. Okay, so we're getting pretty close to what we want here. Hit escape. And I really don't need this anymore.
I'm just curious which axes has the most error, I guess. The most.
That's a good question.
Or is it kind of all of them?
Yeah, they're all pretty bad, but I would say probably X, because the gantry swings back quite a far.
Oh, okay, gotcha.
What you'll notice is, just to satisfy your own curiosity as well, is I would machine something where you know what the dimensions should be. You'll find that the inside dimensions, so the dimensions on this will probably be smaller, because as the milling bit is pushing up against this surface, they'll get pushback, right, in that gantry, because it's got some flex in it, will not push out all the way that it should. And then this one will probably have, let's see, or bigger, pardon me. Yeah, the outsides will be bigger, the insides will be smaller. So, but definitely, and if you really get into it and you'd use the metal mill, then you won't have much of that to worry about. You'll still need to worry about, thousandths of an inch and that sort of thing, but not 1/16 of an inch like we have to worry about right now. Also, the relative measurements are going to be pretty good. It's, if you talk about absolute, like from, it's hard to get a proper Z depth on something, because, that's an absolute measurement from the top of the stock material down to something. But if you're machining a square or something, relatively it's going to be pretty good. Notwithstanding that other stuff we talked about, the gantry flex. It just, all I can really say is try things out and you'll get a feel for it. Okay. So let's do this. We've now got everything that we need to start our G-code production. The way we do that is we go into setup. Incidentally, you can introduce G-code for each one of these if you want. And because we don't have an automatic tool changer in the CNC router, what I tend to do is say, well, if you've got the same tool in both of these paths, both of these operations, then by all means make one G-code file for both of these operations. But if you need to switch tools, then you need to figure out how Linux CNC is going to handle that information on changing tools coming in from the G-code file. And it's got to do with the Linux CNC setup and so forth. So if you're changing tools, create a different G-code file for each of these. If you're not changing tools, then it's fine to run them both together and just do one big G-code. The way you do it is you do post-process. So you either click up on the setup or on the operation, right mouse button click, and you click post-process. You'll see some things that you need to care about and some things that are irrelevant. So at the top, configuration folder, don't worry about that. Output folder, you probably don't care about that so much because you're going to get an editor come up anyway when you're done, and then you can save it to where you want. Program name or number, that's the name of the file. Okay, so I'm going to change that to circles. And then everything else is default. We still want the NC editor to come up. And let's do that. Okay. So, and the other thing that you need to care about is that you're running this for Linux CNC. So in this selector here, you can choose from a whole bunch of different CNC router types. And so this, what we want is Linux CNC. And then all that remains is you click post. Okay, we'll save that file. Come on, editor. Okay, and this is what the G-code looks like. Incidentally, people ask about, specifying inches or millimeters or whatever, and you don't need to worry about it. What Fusion does is encodes the units in the document, and then Linux CNC just uses whatever units is encoded in the document. We won't get into it. This isn't a G-code course, but lots of fun stuff happening in there. And now at this point, I would save this G-code file to a USB drive. I would take that USB drive over to the Linux CNC PC, and then I would go through the process that you just saw in video. Any questions?
Is there any login information that we need to know, or is the PC just open?
Okay, so let's talk about next steps. The PC isn't open. It's you need a sort of a supervised checkout, and it's not a test or anything. It's just for me or somebody that's used the machine before to be with you as you're going through this stuff the first time, especially in a situation like this where we haven't got any hands-on yet. We just like to be there. And so we'll meet up, and the meetup happens when you've got your G-code file ready. So it's simulated, you're pretty comfortable that it's going to do what you want to do. And that session is for the G-code to essentially get you set up, fixturing material, and then running your G-code, and for me to answer any questions that you've got. And at that point, while you're running your first G-code job, then I'm creating your account, and it doesn't take very long.
Okay. Do the computers in the classroom have Fusion 360 installed on them?
There's a few, yeah. And what I've noticed is they tend to be a little bit inconsistent about the setup. They tend to be for example, people have maybe mucked around with the settings a little bit, so that's a drag, but yes, it's on.
have a question about materials.
Yep.
Is there anything that is not okay to use, or is it like anything that's less hard than the bit is millable?
Yeah, I personally, I really advise against anything that's not wood or plastic for the
Yeah,
CNC
okay.
mill, the CNC router. CNC mill, go for it for steel. But yeah, I've tried it before, and what happens is the gantry just starts bucking away, and it's just horrible.
Okay.
Hi, I'm Sean Burnett. I'm going to give you a quick rundown on the CNC room, the practical portion of your CNC education. First thing to take note of here is the master switch. This is your master switch. When you turn on the bed, which I've just done, the first thing to do is check for water supply. So underneath here is the water. It actually takes a little while to start running, but you just take this guy out and make sure there's water coming out. Trust me, it'll start flowing in a second. You can hear it gurgling. So we'll come back to that. The next thing is the software, the Linux CNC software. First thing you do when you have a file, a G-code file that you want to run, you take your USB drive, you stick it in here, and because CNC Linux has some quirks, what I tend to do is find my file. Hang on. Find my file on the USB. I'll go to File Manager here. Over here. And I'm going to take this guy. Where's my CNC example? Here it is, CNC test.ngc. And I'm going to send it to the desktop. Okay, and then I get out of there, and then when I'm over in Linux CNC software, which is this, you can get into Linux CNC software by clicking this icon that you'll get on your screen. Then I go to my file manager opener. I find the file, which for me is Home Sean Desktop. I open up CNC test, and that's how I get in. To enable the bed, there's three-step process actually. One is to flick that master switch that we saw. Next is to enable this software, and then click this orange button. So now we're good to go. We can actually use the controls. Let me just okay, it's all the controls. We can either use these selectors, the axis selectors, in plus or minus. Oops. And or we can use these arrows on the screen, which is actually much easier because you can take the keyboard with you closer to the material that you're working on. This is front and back, your Y-axis. This is your X-axis. And page up and page down is Z-axis. Okay? So let's pause this for a second. I'm just going to show you what I need to do to prep the material physically. So let's go over to here. What I've done, always have a sacrificial board. So I've bolted using these T-slot nuts and bolts. I've got this sacrificial board, and then I've just taken and screwed down the material that I want to cut. Okay? The next is the bit and collet. We're going to do a dry run, but just for now, let's go through this process. This is a collet. They're particularly sized for the bit that you're using. So this is a 3/8 collet, and I'm using a 3/8 shank end mill. I put that in there, and if I try to put this in, it won't work because I need to put in this part first, okay? This collet into the collet nut, and you actually need to give it a little twist, okay? And you know it's in properly when that collet nut is flush with the collet is flush with the nut. Then I put in my bit, and now I'm good to go for putting this onto the spindle. So I'm going to go like this. I need to hold the top. Now I take my 2 wrenches. One is a 17 millimeter, which I put on top, and the other is this particular wrench just for this collet nut. Excuse me. Give it a nice snug fit, and then we're good to go. But because we're going to do an air run, I'm going to take this off. But keep in mind about how far we are down, because we'll do that to estimate our dry run. Okay, next step is to home the machine. Always remember to home all, because if you don't home all, then you need to go through the home all after you've done all your touching off. Touching off is the process of setting the spindle and the cutting bit relative to your stock of material that you want to start chewing up. Okay, so if you'll see, the spindle is at the leftmost, backmost, and topmost position. I'm now going to position it to the part that I wanted to start milling. Shoot. Okay, so now we're going to do our touch-offs. What that is doing is telling the machine where the tip of the cutting bit is going to start, where our stock material is really going to start. So let's just imagine that we have a piece that is roughly this big. We want to do our stock touch-off right about here, okay? So that's going to be our X, this is going to be our Y, and the very top of the material is going to be our Z. I don't have the bit on because we're doing just a dry run. We'll do 2 touch-offs. One is a rough touch-off for our dry run, and then we'll do a final touch-off for our actual cut, okay? So, using the controls we saw earlier, we're going to position the machine. Page down, and I'm going to allow a bit of space for where the bit would come. So let's say that is our rough touch-off, okay? I'm going to select my axis over here, select my Z axis, click touch-off, and accept the defaults. I'm going to go over to Y, do the same thing, and do X, same way. Okay, now we've got our software loaded, or our G-code loaded, and we've got the machine on and enabled. I can hear that water running, so I'm good to go for my dry run. When I do my dry run, it's the most likely time that you'll find that perhaps you chose in your 3D model, for example, a different touch-off point than you imagined. So that's when you'll find out that things aren't quite right. So I'm going to click play, and then I'm also going to be ready with this stop button over here. Okay, so let's click play. You might find this, and it means that the position that you have for your touch-off point probably doesn't match what you think it is, and there's a mismatch between where you're selecting your touch-off point in the material and what you're actually what the G-code thinks. So let's cancel this. Normally at this point I would actually go into my Fusion file and see where I selected my touch-off. Alright, so we've loaded up our G-code file, and you can see Linux CNC is displaying the G-code file. You can rotate your axes and get a bit of a different view. Sometimes it can be not the clearest thing in the world, but you'll get used to it. First thing I'm going to do is select the max velocity. 300 inches per minute is really, really fast. So let's bump that down to something more like 30. Okay. And jog speed as well. It doesn't really need to be that high. Let's cut that in half, say 17. Okay. Now we're going to do our touch-off. I'm going to use the keys that I used before, and back and forth. I'm just going to select this y-axis. I'm going to select my x-axis, and then I'm going to page up and page down actually, to select my Z height. Now that's where I want my stock point to be as aligned with my fusion model. Okay, so now I'm going to touch off each of these points. Take the Z, touch off, accept the defaults. Do the same with Y, same with X, and we're good. So we hear the water running, and we have got our position in place. Also do a double check on the material. The most important thing is to make sure that both your sacrificial board and your stock material is way more secure than you think it needs to be. I've got my machine enabled, so I'm good for a play on this G-code. One thing I'm going to do though is I'm going to have my button positioned over the stop right here, just in case things don't go as I expect them to. Okay, this is our dry run, so let's just click play. Sometimes you'll get a message in Linux CNC that'll say load tool 1, and then click continue. And just click the OK button. So normally we would let this run through a lot of the way of the G code, but I can see there's going to be no surprises in this one. And because we're shooting a video, I don't want to put you through the whole thing. So I'm just going to stop this one. Okay, now we're going to put the bit in for real. And to do that, I need to click page up. Always remember to disengage the bed power before you do anything to do with the spindle. I'm going to take this, I'm going to put it up here, just like before. Give it a nice snug fit, or tighten. And now I'm going to bring this down just so it pinches a piece of paper. It's sort of a piece of paper. With the page down, oops, re-engage the bed. Okay, page down. And I just want to barely feel the pinch. There we go. Now, at this point I'm going to set my Z. You don't need to have X and Y and Z all lined up at the same time to touch off each axis. You can do them independently. So while we've got a position on Z, I'm going to touch off. Okay, and then I'm going to page up, get off that piece of paper, and I'm going to position to a spot where I want to start my touch off point. Okay, so I'm pretty happy with X and Y for both of those. So now I'm going to touch off X, and I'm going to touch off Y, and I'm good to go. Again, I'm going to be ready with that stop button. Don't be surprised when the actual cutting doesn't start at your touch-off point. Fusion tends to hit any random point for its beginning within your model. Okay, I think you probably get the idea here. So I'm going to cut it off. I'm going to raise the bit. And that is pretty much all there is to it. I'm just going to go through my list here to make sure I've covered everything. Good. Now switch to PC, sign in. Home before you start anything. Check the water. safety. As with any, rotating tool, don't put long hair near it. Don't put any loose clothing near it. Just treat it like a drill press, one that's autonomous and can move suddenly. Sacrificial board. Always use a sacrificial board. When you're using a USB stick, choose one that's small. This is an ancient version of Linux CNC, so it can have trouble mounting large drives in that it'll take a really long time. We've gone through this Linux CNC controls, done the touch off, we've done an air run, and last step is to clean up. And then you're good to go.
All right. Thanks, Sean.
Thanks.